Lesson 1F, Bohr Diagrams. In the 1920s, a fellow named Niels Bohr came up with a simple description of the atom. He and another fellow named Rutherford identified that the center, or the nucleus of an atom, housed the protons and the neutrons, while the electrons traveled around the nucleus in orbitals. He found that the electrons traveled in orbit around the nucleus and named the inside shell the K shell, the middle shell the L shell, and the outer shell the M shell, just like the middle of the alphabet, KLM. He also determined that the K shell must completely fill first, then the L shell, and finally the M shell could fill. The L shell can hold 1, 2 electrons, while the L shell can hold 1, 2, 3, 4, 5, 6, 7, 8 electrons. The M shell can hold a maximum of 8 electrons as well. 1, 2, 3, 4, 5, 6, 7, 8. Notice how we draw the electrons in singles and then in pairs? This helps us with our counting. For grade 8 science, we only need to worry about the first 3 shells. We'll look at the other shells in grade 11 chemistry. Remember, K shell can hold a maximum of 2 electrons, L can hold a maximum of 8, and M can hold a maximum of 8. And K must fill completely before L can start, and L shell must completely fill before M can start. Let's look at this example of lithium. Looking at the periodic table, we see lithium has an atomic number of 3, so it has 3 protons. It is neutral, it's elemental, so it has 3 electrons as well. The electrons must go in the K shell first, 1, 2. Remember, it can only hold 2 electrons, so the third electron goes into the L shell. The term valence shell is used for the outermost electron shell with any electrons in it. In this case, it's the L shell with 1 electron. Our next example is lithium ion with a +1 charge. From our previous example of elemental lithium, we see that K holds 2 electrons, while L holds 1 electron. Lithium has 3 electrons in total. It's lithium, so it must have 3 protons. In order for the lithium ion to have a +1 charge, it must have more protons than electrons. It has 2 electrons. The 3 protons and the 2 electrons, the 3 pluses and the 3 minuses, give the lithium ion a net charge of +1. This is the Bohr diagram of the lithium ion. Hydrogen has 1 proton and 1 electron since it's elemental. This 1 electron goes into the K shell, here. Our next example, sulfur, has 16 protons, and therefore 16 electrons as its elemental or neutral. Here are the electrons, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. The valence shell is the outermost electron shell with any electrons in it. In this case, it's the M shell with 6 valence shell electrons. For sulfur to form a -2 ion, it must have more electrons than protons. Sulfur has 16 protons. In order for it to have a -2 charge, it must have 2 more electrons than protons. It has 18 electrons. The 16 protons, or the 16 plus charges, and the 18 electrons, the 18 minus charges, combine to make a -2 charge. Here are the additional 2 electrons, 1, 2. Remember, the first shell or orbital is called K, and it can hold a maximum of 2 electrons. The second shell or orbital is called the L shell, and it can hold a maximum of 8 electrons. The last and outermost electron shell for grade 10 science is called the M shell, and it can hold 8 electrons as well. There are 2 acceptable ways to draw Bohr diagrams. If we use elemental potassium, for example, we determine from the periodic table it has 19 protons, its atomic number is 19. If it's elemental, it has 19 electrons as well. For the most common isotope of potassium, it will also have 20 neutrons. We can draw the diagram using concentric circles for K, L, and M, and it would look like this. Note how the contents of the nucleus is listed in full. We can also avoid having to draw all of these circles by drawing arcs to represent the shells. Then we can write the number of electrons as integers. Our example, potassium, would end up looking like this, where 2e stands for 2 electrons, 8e stands for 8 electrons, and so on and so on. The valence shell would have a single electron, 1e.